So today we will see about propositional logics. Okay, so yesterday we saw that uh, how the logical languages are related to our natural language and why do we use it, right? So in propositional logic there are syntax, then semantics, and then inference rules. Okay, so first of all we will see what are propositional symbols. What are propositional symbols? So we will write propositional symbols. Okay, so propositional symbols, or they are also called as atomic formulas. Propositional symbols are also called as atomic formulas. Okay, so they are also said as atomic formulas. Now see, what are they? Formulas that cannot be subdivided. Okay, formulas that cannot be subdivided. Formulas that can't be subdivided. Okay, so now see, more complicated formulas can also be derived from the atomic formulas using connectors. Okay, so using these atomic formulas, more complicated formulas can also be derived. And how we are going to derive it? Using connectors. So from here you can derive more complicated formulas, more complicated formulas. And how you are going to derive the more complicated formula? Using connectors. Using connectors. Okay. And now see, what are logical connectors? Right. So we will see that what are logical connectors here. What are logical connectors? Logical connectors are these symbols like negation and or implications and bidirectional implications. Okay, so they are connectors. So using these connectors we can derive more complicated formulas from atomic formula. Okay, now see, when we are talking about formulas, then we must know that हम किसे फॉर्मूला बोलते हैं. लेट अस से इट इज़ रिटन ए एक सिंबल है, तो क्या ये फॉर्मूला है? यस, इट इज़ अ फॉर्मूला. negation of A, is it a formula? Yes, it is a formula. Negation of B implication C, it is also formula. Why? Because these two symbols are connected via a connector, a logical connector. Similarly, negation of A and negation of B implies C, and then let us say union of negation of B or D. So this is also a valid formula. This is also a valid formula. Why? Because the symbols like negation of A, negation of B implies C, and negation of B or D, they are connected through connectors. Here also the individual terms are connected through connectors. Similarly, negation of negation A, this is also a valid formula. Okay. Now, A negation B, is this a valid formula? No. Why? Because A and B are not connected to each other. Negation B is itself a symbol and A is itself a symbol. There is no connectors in between, right? So, we can say that this does not represent a formula, right? Similarly, A plus B, if it is given that A plus B, then it is also not a formula, because we don't know what plus means here. We don't know what plus means here. Now see, negation, regarding negation, if it is given something like this, that A negation B, so here negation of B is a separate symbol and A is a separate symbol. So, these two must be connected with any other connectors like OR, like AND, or implication or by implications. Similarly, placing negation, just simply placing negation between two symbols not make it a formula. Okay, now coming to, so what we can say that syntax, are just symbols with no meanings attached. Syntax are symbols with no meaning attached to it, with no meaning attached to it. And the job of semantics is to assign meanings to it. So, job of semantic is to assign meaning to it. Is to assign meaning to syntax or to symbols. Okay. So, this was about syntax and semantics. Now coming to models. Okay. See, models have a variety of definitions, right? Variety of definitions, especially when we are reading machine learning. तो वहाँ पे जो मॉडल का मतलब है दैट इज़ डिफरेंट फ्रॉम व्हाट वी आर गोइंग टू टेक हेयर, एटलीस्ट इन द लॉजिक. तो लॉजिक में जो हम मॉडल का मीनिंग ले रहे हैं ये डिफरेंट है. तो हाउ वी आर डिफाइनिंग इट, अ मॉडल W in propositional logic, in propositional logic is an assignment of truth values to propositional symbols, is an assignment of truth values, assignment of truth values to propositional symbols. Okay. So, it is basically assignment of propositional symbols, assignment of truth values to propositional symbols. So, now let us say example, let us take an example 3 propositional symbols we are given. हमारे पास 3 propositional symbols दिए हुए हैं, and they are A, B and C. Okay, so how many possible models are would be there? So 2 raised to the power 3, that is equal to 8 possible models will be there. Possible models. Okay, so how it will be? Let us say this is A, this is B and this is C. So one case would be 0, B is also 0 and C is 0. Similarly, the second case will be A 0, B 0 and C as 1. Okay, so these every elements जो हम देख रहे हैं यहाँ पे, then इसके बाद क्या आएगा? A 0, B 1, C 0. इसके बाद क्या हमारे पास आएगा? A 0, B 1, C 1. इसके बाद हमारे पास आएगा A 1, B 0, C 0. फिर हमारे पास आएगा A 1, B 0, C 1, then A 1, B 1, C 0 और लास्ट में A 1, B 1 और C 1. So if you count them 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 worlds or 8 different models. Okay, so if you take any one of them, let us say I am taking this one. Okay, if I am taking this one, then this element, or we can say every element, is a model or world. Every element is a model or world. Is it okay? So we saw about syntax, about formulas, and then we saw about models. Okay, so what are models? And then after this we will talk about, what we will be talking about is interpretation functions. Interpretation functions. Okay, so what is an interpretation function? Just let me decrease its size a bit, and then let me try how it writes. Okay, so this is not fit for our use, right? Yes. So now interpretation function, let us say let f be a formula, f be a formula, and let w be a model. अभी हमने देखा कि w क्या है, मॉडल क्या है, we saw. So let w be a model. Then an interpretation function, then an interpretation function I f comma w returns true or 1. When it will return true? When w satisfies f. When w satisfies f, okay, when w satisfies f, and it will return 0, it will return false or 0 when w does not satisfies f, doesn't satisfy f. Okay. So, this is interpretation function. We can also say that if comma w binds formulas and models, binds formulas and models. So, we saw that these formulas are coming from which place? They are coming from the syntactic land or syntactic world, the world of syntax, okay, syntactic world, they are coming from syntactic world, and these models are coming from semantic world, okay, these are coming from semantic world. Right. And how do we denote this is, let us say we are having f, let us say we are having I f comma w, here it is f, a formula, and then this I f comma w connects a function, a formula f to a world w. Let us say this is the w in this model world. Okay. So, it connects a formula to w. What it is doing? Interpretation function is connecting a formula to w. Right. Now, let us see, for a propositional symbol, for a propositional symbol p, this p may be, let us say it is example a, b and c, ठीक है, example ले लिया, ये symbols है. Then I of interpretation function of p comma w is equal to w of p. What is w? W is an assignment, okay, and this p can take which kind of values? This symbol can take Boolean values, this p can take Boolean values. So, let us see through an example. Let w is equal to a, that is assigned a value of 0. That means this model is assigned the value 0 or a is assigned the value 0, and p is equal to a. Okay. So, now if I evaluate this I p comma w, that means I a comma a assigned the value of 0. Okay. So, this will be equal to 0 because the value of a is given to be 0. So, like this we do evaluate the interpretation function. Okay. So, in the next class we will see a recursive case for this interpretation function, that how using two formula we define further cases. We will see an example, then we will read about knowledge basis, and then further we will move towards entailment, contradictions, or there are three terms in entailment, contradiction and contingency. So, these things we will learn later on. Okay, thank you.